Okay, so we will see a new topic, that is the LR method to find out the eigenvalues. Okay, so the title is LR values. So you are already familiar with this particular method. Uh, we have already covered some portion in this. Just give me a minute. We have to go for 2 by 2 matrix, not 3 by 3 matrix. Okay, so here is my 2 by 2 matrix. I think yeah, so we can take a simple matrix. Okay, let me write down the problem first. Okay, so now we have to find out the eigenvalues of a matrix A. It is a simple 2 by 2 matrix. The values are 4, 5, 5 and 6. Okay, so it's a just a 2 by 2 matrix, right? Okay, because 3 by 3 it will be very difficult and it involves many calculations. So let us try 2 by 2 matrix. Okay, now in this LR method, what exactly we are doing, that we will see. Okay, so now let us say you have a matrix, okay, for which you need to find out the eigenvalues. Okay, now what we are going to do is we are going to divide this matrix into two parts, that is L and U. This we have already done in the Cholesky method. Okay, so no need to explain this. So once the matrix is broken into two parts, that is L matrix and U matrix. Okay, so I'm writing a subscript over here. I'm making this as L1 and U1. Okay, so the original matrix A is broken into L1 and U1 such that if you multiply L with U, you are going to get your original matrix back. Okay, now once these two matrices are calculated, I am going to generate A1 matrix, which is a new matrix, and this matrix will be a product of U1 with L1. The exactly reverse of that. Okay, so this will be a new matrix. So basically we have this matrix, and after one cycle I have created A1 matrix. Okay, then once your A1 matrix is created, I am going to break this A1 matrix again into two parts. One is L and one is U. Again I am doing this. Okay, so let us call this as L2, this call U2. Okay, so again it's a repeated process. Once the value of L2 and U2 are known, then you can generate A2 matrix by multiplying U2 with L2. Okay, are you getting this? Okay, so now here we have started with A, we have generated A1, and then we have generated this A2. Okay, now you have to keep on doing this process again and again, unless and until this A value or this A matrix becomes upper triangular matrix. Okay, so you have to repeat this again and again till it becomes a upper triangular matrix. Okay, now the idea is, if it is a 2 by 2 matrix, so there are 4 elements. Okay, 2 rows and 2 columns, so total there are 4 elements. If it is 9 by 9 matrix, you will have 3 rows, 3 columns, you will have 9 elements. Okay, so depending on the number of elements, you have to go for maximum number of cycles. So if it is a 2 by 2 matrix, you have to go for at least 4 cycles. Okay, if it is a 3 by 3 matrix, you have to go for at least 9 cycles. Okay, so from A, for example, if I go for 2 by 2 matrix, so from A, I'll generate A1, I'll generate A2, I'll generate A3, I'll generate A4, and then I'll stop. Okay, in between, if you are getting a matrix which is a upper triangular matrix, then also you can stop, because further if you do the calculations, it is not going to make any difference, because L and U, they are going to remain same. Okay, now once this A matrix is becoming a upper triangular matrix, so if I draw a picture of a matrix which is, let us say, 3 by 3. Okay, so if it is a upper triangular matrix which is having 3 by 3, so there will be a value over here, value over here. Okay, since this is upper triangular matrix, there will be values. Okay, and in the lower triangle you will have zeros. Okay, now the diagonals which are there in this matrix, this will be a diagonal element, this will be a diagonal element, and this will be a diagonal element. These diagonal elements, they are nothing but your eigenvalues. Okay, again I'll repeat, the diagonal elements of the upper triangular matrix, or you can say the A matrix, these are nothing but the diagonal values. So basically this value is lambda 1, okay, this value is lambda 2, and this value is lambda 3. Okay, so once the value of lambda 1, lambda 2, and lambda 3 is calculated, you can calculate eigenvectors. We have already seen eigenvectors, how to calculate eigenvectors in the previous class. Okay, the same process can be adopted over here. Okay, so now we just imagine if you are solving the problem of 3 by 3. So you see the calculations which are involved in 3 by 3 is very large, because first of all you have to break a 3 by 3 matrix into 2 parts. Okay, so 2 part means we have at least 9 unknowns. Okay, so it is going to take a lot of calculations. Then once those L and U are there, you have to swap. Again you have to multiply so that you can get a new matrix. So itself, doing a one cycle, it will take at least half an hour. Do you agree? That's why we are going for a 2 by 2 matrix, just for a demonstration purpose. Okay, so I hope the method is clear to everyone. Okay, so let us try to solve, and let us try to find out what are the eigenvalues of this particular matrix. Okay, so now in this case, what exactly we have to do? We have to break this into 2 parts. Okay, one is the lower triangular matrix and one is the upper triangular matrix. Okay, so now as you know, in the lower triangular matrix, you have diagonal values as 1. Okay, the upper triangle is 0, and in the lower triangle you have second row and first column. Correct? Because it's a 2 by 2, right? And in the upper triangular matrix, you have U11, U12, this will be 0, this will be U22. Okay, so such that basically this is your L matrix, this is your U matrix. If you multiply it, you should get your original A matrix. Correct? Barabar? So if you multiply this, this should be equals to 4, 5, 5, and 6. Okay, so if you remember, we have already done this plenty of times in the previous classes. So if you want to have this 4, if you generate the equation, so like you will have 1 into U11 plus 0 into U12, this should give you 4. Barabar? So ultimately this value, okay, that is this value is going to become 4. Okay, and remember this particular row is exactly same in the upper triangular matrix. This we have already seen, so I am not wasting my time. This will be also 5. Barabar? If not, if you want, you can do this manually also. I am sure you will be getting this as 5. So this is nothing but the first row and the second column. So this will be something like 1 into U12 plus 0 into U22. This should be equals to 5. Am I right? बराबर है. Okay, and if you solve this you should get u12 as 5. बराबर है. ठीक है. So on the similar lines you can have this one also, third row. So this will be something like L21 into u11 plus 1 into 1 into 0. That is this particular row with this particular column. बराबर है ना. So this should give me what? 5. So can anybody give me what is the value of u11? Sorry, u11 is already known, that is 4. L21 कितना आ रहा है? Sorry, 5 by 4. So can I write 1.25? Okay, so this value, so this is going to give me this value as 1.25. बराबर है. And lastly you can have the product of say L21 multiplied by u12 plus 1 into u22. This should be equals to 6. I'm talking about this part. Okay, and this should give me the value of u22. How much is u22? Anyone? Minus 0.25. 1 by 4. Okay, so this is minus 0.25. ठीक है. So 2 by 2, quite simple. So you have a L matrix and you have a U matrix. Okay, so let me write down L and U one more time for you. So your L matrix will look like this. So this is 1 0, this is 1.25 and this is 1. Okay, everybody is getting these answers, है ना. And your U will be something like, you have this will be 4, this will be 5, this will be 0, and this will be minus 0.25. Okay, so now what I am going to do is, since we are doing this for the first time, so I am going to call this as L1 and U1. Okay, so basically what I have done, the A matrix is broken into L1 into U1. Okay, now I am going to generate A1 matrix now. Okay, so a new matrix will be generated. Let us call this as A1. Now A1 will be U1 multiplied by L1. This will be a new matrix. Okay, and this new matrix should be a upper triangular matrix. Okay, so let us do that. So I'm going to write down the upper triangular matrix first. So this is 4, this is 5, this is 0, this is minus 0.25 multiplied by the lower triangular matrix is 1, 0, 1.25 and 1. So if you multiply this, you should get one new matrix. Okay, so the first value will be 4 into 1 plus 5 into 1.25. How much is this? 10.25. Okay, so this is 10.25. Okay, then this value should be 5. Am I right? Okay, then this should be 1.25, I suppose. Okay, and this should be minus 0.25. I don't need calculator for this. Have I done anything wrong? Is it okay? बराबर है. Now you see, this is not a upper triangular matrix. बराबर है. This is a regular matrix. It has got some value in the lower triangle which is non-zero. Okay, so this is your A1 matrix. So now what you have to do? You have to go for another cycle, so that you have to break this A1 matrix into once again two parts. One is L and one is U. Let us call this as L2 and U. Sorry. I'm not able to hear you properly. Oh, my mistake. Sorry. ये कितना आएगा? -3125. Okay. So you see it is closer to 0. Okay. It is not 0. It is closer to 0. So we have to go for one more cycle. Okay. So we have to break this into two parts. Okay. So now again in two parts, I should have this is 1, this is 1, this is 0, and this is L to 1. Okay. Multiplied by this should be U11, U12, this will be U22, and this will be 0, and this should be equals to 10.25. This is 5, this is minus 0.3125, and this is negative 0.25. Okay, so one by one we have to now calculate the unknowns which are there in the lower triangular matrix and which are there in the upper triangular matrix. I am sure your U11 value will be something like 10.25. They are exactly same. Okay. And this value should be 5. Okay. Now you please give me this value and please give me this value. Yes, online students, are there any queries, please?
No, sir.
Okay, please do this. Give me the value of L21 and U22. Am I going fast? ठीक है?
Yes, sir.
Yes, anybody L21? Sorry? Just a moment. Minus 0.0304. Anybody is getting this answer? Okay, good. Just get me the value of U22 now. Sorry, let me note down. Yes. How much? Minus 098. Yes. ठीक है? So after the calculations, you are getting the L. I'm calling this as L2 matrix as something like 1, 0. This is minus 0.0304 and 1. So this is your L2 matrix, and your U2 matrix is something like this. That is, this is 10.25, this is 5, this is 0, and this is negative 0.098. Okay, so now you have L2 and U2. So now you can generate another A matrix. Okay, so earlier we have generated A1 matrix. Okay, so now I am going to generate A2 matrix by multiplying the upper triangular matrix with the lower triangular matrix. Okay, So let me write down this. So this is 10.25, this is 5, this is 0, this is minus 0.098 multiplied by, you have 1 0 minus 0.0304 and 1. So this should give me the value of A2 matrix. Okay, please multiply this. ध्यान नहीं है बेटा तुम्हारा, ध्यान दो. ओके. Yes, anyone? A2 matrix. आया किसी का? Yes, please tell me the values, please. Final values. Sorry, 10.095. Okay. 5. Okay. 0029. Okay. Minus 0.098. Okay. So now you see we have A matrix, we have generated A1 matrix, then we have generated A2 matrix. Okay. And you can see the nature of A2 matrix, it is very close to the upper triangular matrix because there is only one element in the lower triangle and it is very close to 0, that is 0.0029. Okay. So let us go for one more cycle. Okay. Let us go for one more cycle. So in this, what you have to do is you have to break the given matrix again into two parts. Okay. So this matrix, okay, so this matrix has to be broken into the L matrix. So I am going to call this as L3 multiplied by U3. Okay. So your L3 will be having shape something like 1 0 L to 1. This will be 1. Okay. Multiplied by, you have U11, U12. This will be 0 and U22. Such that if you multiply this, you should get the original matrix, that is 10.095. This will be 5. This is 0.0029, not 39. Okay. And this is minus 0.098. Okay. So again, if you do the calculations, I am sure the U1 value will going to be same, that is 10.095. This value will be definitely 5. Please give me the value of L21 and L22, U22. Anyone? Yes, online students, anyone answers? L21 and U22? Yes,
सर
anyone?
वो 10.098 होगा वो 10.095 सर
एक सेकंड ना. Yes,
10.098 है
Prajwal, you
वो
are
यू
saying
वन वन
something?
098
10 point?
U11
कौन सा वाला?
U11
सॉरी, U11
सर
में
वो
तो
वही
मैंने
टेन
ऑलरेडी
पॉइंट
लिखा हुआ है
जीरो
बेटा.
नाइन एट आ रहा है
I want L21 and
सर
L22.
यू
Oh, sorry,
L21
U22.
इज 0.000294
L21 is 0
0 0
point.
0 2 9
हाँ,
थ्री टाइम्स
just let me write down. Huh? It is 0.000.
294
Sorry,
294
24.
294
एक काम करते हैं 0.002 लिख देते हैं, ठीक है?
यस सर
ओके.
यस
एंड U22, anyone? Yes, anyone? U22 कितना आ रहा है? 0.123 माइनस 0.0994. L21 बराबर है 0.0002. ओके, ठीक है. सो I'm considering these are the correct answers. Okay, so let me move ahead. So your L matrix, specifically now I'll call this as L3 matrix. So L3 matrix will be something like 1 0. This is 0.1230 and 1. Okay, now this is your L matrix, and your U3 matrix is something like this, that is 10.095. This is 5, this is 0, and this is minus 0.0994. Okay, so now we have A matrix, we have generated A1 matrix, we have generated A2 matrix. Now we have to generate A3 matrix. Okay, so your A3 matrix will be the product of U3 with L3. Okay, so let me write down the U3 matrix first. So this is 10.095. This will be 5. This will be 0. This is minus 0.0994 multiplied by your L matrix is 1 0. This is very close to 0. Okay, multiplied by this. So this should give me the A3 matrix. Okay, so can anybody give me the values of A3 matrix? Yes, anyone A3? Just a moment. Huh? This is 10.096. Okay, 5. Okay, 19. So I'm making this as 2. And lastly, 99. Okay, I'm sure you are getting answers which are close to this one. Okay, so now we see we have A, we have generated A1, then A2, and then A3. And if you look at A3, the A3 matrix is basically upper triangular matrix. Okay, lower triangle we have only one element, and if you observe very carefully, it is converging towards the 0. I'm sure if you go for one more cycle and if you get the value of A3, it will be definitely exactly 0 or maybe even 0.0000 something like that. Okay, so if you can notice, if you go for one more cycle, this value will take shape of 10.1. Okay, because I already know the solution, that's why I'm telling you this. And this value will be something like minus 0.1. This value will definitely be 0 और ये value 5 ही रहेगी. ठीक है, so in short, the diagonal members which are there in this new A matrix, they are called as eigenvalues. Okay, so here the eigenvalue, the first eigenvalue, that is lambda 1, is nothing but 10.1, and your lambda 2 is nothing but negative 0.1. Is it clear to everyone? Okay, now still we have time, so what we will do, we will solve the same problem using the direct method, because direct method, it's a just 2 by 2 matrix. It will be hardly taking couple of minutes to solve this. Okay, so let us try to solve this using the direct method. Okay, so here I am putting a line over here. Okay, and then so I'm just going for the original matrix. So your original matrix is 4, 5, 5, and 6. Okay, so you have this A matrix as 4, 5, 5, and 6, and in the direct method, what you write? Lambda into I. This should be equals to 0. बराबर है? A minus lambda into I, this should be equals to 0. So if you do this, so this is going to result in an equation something like 4 minus lambda, this will be 5, this will be 5, this will be 6 minus lambda, this has to be equals to 0. Okay, right? So now if you calculate the determinant of this, so this is 4 minus lambda into 6 minus lambda minus 5, 5 equals to 0. So this, if you expand this, you are going to get the second order equation, which is something like A x square, or rather in place of that, I can write A lambda square plus B lambda plus C equals to 0. Correct? Okay. So can you give me these values, please? Just expand this. 4 minus lambda into 6 minus lambda minus 5 into 5. This should be equals to 0. Give me the values, please. एक this is lambda square. Okay, minus 1 equals to 0. Okay, and you already know the solution of this, that is b square minus 4ac. Okay, usko tum use karo. So here the solution of this is lambda equals to minus b plus minus under root of b square minus 4ac divided by 2, and this should give you the value of lambda 1 and lambda 2 as 10.1 and minus 0.1. Please check whether you are getting it or not. Alright, everyone, please do the calculations. So see, direct method here, it is very easy because it's a 2 by 2. But if you go for 3 by 3, it will be a difficult one. 4 by 4, भूल जाओ. ठीक है, because it involves a lot of calculations. But with the help of this LR method, you can easily write a computer program, and with the help of computer program, it will be quickly done. As far as direct method is concerned, there is no programming for direct method. Okay, everybody is getting these answers. Please verify. Same answer should be there. Okay, fine. So let us stop.